Okay, students, let us quickly complete this question as well. Yes, I am audible, clear. This is the last question of your exercise and thereby last question. Okay, just the last question of this exercise. This is question number 12. I hope you can write down given and to prove by yourself. Given is ABCD is a trapezium with AB parallel to CD and AD and BC as equals. And secondly, you have to write down to prove. These are all the 4 proofs that you have to do. I'll start with construction. Construction is extend AB to E such that CE is parallel to AD. Such that CE is parallel to AD. Okay. Now we'll start with the proof. For quadrilateral AECD, for quadrilateral AECD, you have AE parallel to DC. Why? Because AB was originally parallel to DC and A is nothing but extended version of AB. Okay, and secondly, you have line AD as parallel to CE. Why? Because we have made construction so by construction. Okay, so with all this, since a pair of opposite sides are parallel, since pair of opposite sides are parallel, so AECD is a parallelogram. Okay, so this is the first part. First of all, we will do 2 things. We will prove that AECD is a parallelogram, that we have done. Secondly, what we will do is we will prove that BEC is a isosceles triangle. Okay. Now, in triangle BEC, you have AD and BC equal. AD is equals to BC. It is given to you. And secondly, I will say that AD is also equal to CE. Why so? Because opposite sides of parallelogram are equal. Parallelogram are equal. So, this becomes an isosceles triangle, and angles opposite to equal sides of an isosceles triangle are also equal. Angle CEB will be equal to angle CBE, and I will say both of these are equal to x. We will say both of these angles are equals to x. This is x and this is x. Okay. Now moving on. Moving on with the proof. Now see, for parallelogram ADCE, or we can say AECD, for parallelogram AECD, since adjacent angles are supplementary, supplementary, So what we have, angle A plus angle E is equals to 180 degree. Angle A plus angle E is equals to 180 degree. Okay, and we already defined angle E as x, so angle A will be equal to 180 degree minus x. We mark it as equation number 1. Okay, next is on line AB AE at point B. Okay, if the diagram is not clearly visible to you, kindly see the diagram provided in the book or the diagram you have made just now. Okay, or revise the video and draw the proper diagram in your copy and then view that. On line AE at point B, angle CBA plus angle CBE should be equal to 180 degree. Reason being linear pair. These are pair of linear pair angles, so these are supplementary. Now CBE we have already defined as x. Angle CBA will be equal to 180 degree minus x. Why? Angle CEB we already defined it as x. So this is our second equation, and by comparing equation 1 and 2, by equations 1 and 2, angle A was also x, angle CBA was, angle A was also 180 minus x, angle CBA is also 180 minus x, so angle A should be equal to angle CBA, or you can say angle B. This is the proof of first part. Now for second part, let me drag the question. For second part, I need more space. Okay, so I'm dragging the question upwards so that I can get more space. We have conclusively proved that angle A and angle B are equal. Now we'll start for the second part. For second part, this angle E was called as x, this angle was also called as x. Okay. Now for the second part, since opposite angles of a parallelogram are equal, of a parallelogram are equal, so angle D is equals to angle E is equals to x. Okay. And secondly, let us mark this as equation number 3. Okay. Also, since AE is parallel to DC and BC is transversal, so angle let us say DCB will be equal to angle CBE because they are pair of alternate interior angles, and angle CBE is x, so this is fourth equation, angle DCB. Okay, by equation 3 and 4, by equating these two equations, you can easily get, see, angle D is also x, we have proved that this angle is x, this angle is x, hence both of these angles are also equal. Angle D is equals to angle C. This is the second proof. Okay. For the third and fourth part, I will redraw the figure for you. so that we can easily do third and fourth part and you can understand how they are different from rest of the question. This was the trapezium A, B, these are equal sides, and this is the third side. This is trapezium A, B, C, D. This is A, B, C, D. In third part, question is asking us that we have to prove that triangle ABC and triangle DBC are congruent. Triangle ABC and triangle DBC are congruent. So, in triangle ABC, I misspoke, and triangle ADB. We have to prove that triangle ABC and triangle ADB are congruent. Okay, I misspoke earlier. In triangle ABC, it is this triangle, and ADB, it is this triangle. We have to prove that both of these triangles are congruent. That is quite easy. AB line is common. Secondly, we are already given that AD line segment and BC line segment are equal. AD is equals to BC, given. And thirdly, we have already proved that angle A and angle B are equal. This complete angle A and this complete angle B are equal, proved above. Okay, so in that manner, triangle ABC will be congruent to triangle angle A is equals to angle B, angle C is equals to angle D, remaining is A, is congruent to triangle BAD. And by CPCT, you can say that this diagonal BD and this diagonal AC are equal. AC is equals to BD. Okay, so with this exercise has been completed. We will continue with the next exercise tomorrow, actually on Monday.